Hey guys, welcome to another episode of the NILG.AI podcast. Today we are in beautiful Essen in Germany at Iqony's headquarters. We have Dennis Braun with us. He's an engineer of Iqony from the System Technologies department. And I will say it's already a personal friend of exchanging ideas around content and how to share these wonderful ideas we share here with all of you. Thank you, Dennis, for this opportunity.
Thank you, Kelvin, for coming. And as you mentioned, the content, I think it's a picture similar to what we do with the energy data. Yeah, the content, we come from two different sides, but we work on the same topic to entertain you or to help you with your data. So let's see what we can dig out here today together.
And oftentimes to help us ourselves understand the topics that we exchange, I will say. I learned a lot by doing this. So you place in your LinkedIn a sentence that I like a lot, which is the GPS of energy data. So what does it mean for you, this phrase?
I think the energy world is now, today, pretty complicated, but it was already complicated 10, 20 years ago. And 20 years ago, I was studying engineering with energy topics there. Since 2010, I'm here with Iqony or STEAG back then. So it was always complicated, but you need reliable information. And one day I said, why is it not that easy as it is in your car? Yeah, I'm that old. I know maps, and I also know the time where you print it out from the internet and you would just drive by whatever's on your piece of paper. You would wait for the right road to take an exit. Once in Münster, I took like a 50-kilometer detour because I missed one road. Yeah, so these days you plug it in your Google Maps. Yeah, you even say where you want to go. It finds out the street address automatically. Then it tells you the traffic is changing. It's so easy. I have trust in that system. I have experience. I know when I cannot trust it. So isn't that what we want for our energy data at home, for our house, for our heating, for our PV, for our power plants? So that's for me where it all comes together. And I was hoping for solutions, wherever they come from, but that are as easy to use for energy generators like a GPS in the car. And so the idea is to say that's what I demand from such a system. Yeah, not fancy screens and hundreds of alarms. Really tell me now left. Wait, no, keep going. Yeah, or traffic jam ahead. That's what I want. That's not what's available everywhere all the time. But more or less, that's the idea.
Okay. So for us end users, energy is as simple as turning on the light and magic happens. But in the background, it's more like a jungle, right? So it's, as you're saying, it's a very complex setup. So why energy data? What's the importance of such data behind the scenes, behind your house, during generation? So how can you use this kind of data?
Good question. Well, electricity has no mercy with us. Whatever is used in one moment in time has to be produced in one moment in time. And in the past, it was all simple. You had the big power plants in Germany. You had different areas. The plants and the grid were communicating with each other, and it got more complicated. And so these days, I can turn on my whatever energy consumption, however I feel. I'm following somebody on LinkedIn who's even having a hydrogen generator that consumes electricity, and he can turn it on and off however he wants. It's not so much, it's not megawatts of electricity. But since everybody does what they want to do, it's hard for the grid to conquer that. And what people tend to forget, in the past we had those huge generators with lots of metal in there, so there was inherent a lot of energy stored. All fine, you can replace that with batteries, with whatever, with a smarter control mechanism. But we have to take care of that. We cannot just turn off all the power plants, then hope it works just like that. I don't want to be too grim here, too dark. But I would be more happy if more people would see the full picture, right? And look at the full year, all weather conditions and so on, and not just optimize themselves, but optimize the overall picture. That was in the past, when STEAG was responsible for planning large-scale power plants. We were always proud to say, we look at everything. We're not just one manufacturer. No, independence there. Look at everything, optimize it overall, and that's what I want in the modern world as well.
Okay. So energy has become more of a complex landscape because now we have uncertainty, both, let's say, on energy generation because it's more decentralized and distributed, maybe with a PV on your roof or And also consumption, I believe, is more decentralized now. Before we only had like, let's say, factories, the main consumers of electricity, and now residentials are also getting into place both on generation and consumption, right? So with higher uncertainty in a decentralized environment, it's like the perfect recipe to apply AI to reduce this uncertainty. So where do you see AI being applied on the energy industry?
I have some idea, but Kelvin, maybe before we go into that, what is your understanding of AI? What is mine? I read a couple of definitions. I think when it uses those neural networks, machine learning, you can already call it AI. But how far would you take this understanding of AI before we go deeper?
Perfect. So for business people, okay, I always say AI equals nowadays predictions, okay? And a prediction is simply more data, okay? You have a set of data points, and the AI will extend that set of data points with additional data. And more data is all you need to make better decisions, right? So for me, an AI is any prediction system that helps you make better decisions. I know that's very broad in terms of a definition. If you want a more technical definition, I will say it's about sensing the world, understanding what's going around, and then acting towards a certain goal.
And I'm thinking about a simple example. Would I consider going to Frankfurt and I guess ask you Google Maps or GPS again? Hey, next week, Friday. Nobody knows what's up then, but still I get an estimation based on the data it knows. That's AI, right?
It's more data. Yeah. In the end, you're getting an additional data point that will allow you to make a better decision around where you need to leave your house to arrive to Frankfurt, for example.
In this understanding, I think the whole data and AI helps a lot. But also, I think the foundation is important. For us, it's all a given. Yeah, we're in a nice studio here with a fast internet connection, everything. But do we have all the data? In Germany, many of those meters at home are not connected anywhere, so nobody knows how much it's using there. 2 years ago on NBIT in Frankfurt, I learned that in Germany, like 7% of the data about the local grid is just known. Yeah, so there's lots of unknowns. And if everybody of my neighbors has this small plug to charge their electrical car, and we talk maybe, let's say 10 people come home same time, plug it in same time, just 11 kilowatts or something like that, yeah? That's already a huge burden on the grid. And therefore, whenever either AI is able to steer it directly or give the right information to say, well, tonight it's going to be very costly and you will save a lot of money, and tonight we expect 0 cents per kilowatt hour plus grid fees. Yeah, if people know that, I think they will react accordingly. But we have to empower the people to make those decisions and make the right decisions. Yeah, not talk about a little light bulb all the time and forget their car or their heating or their stove or whatever. So the huge consumption should also be in the picture.
Okay, so balancing, let's say, demand and supply sides of energy, as you mentioned, energy has to be produced at the time it's consumed, right? So balancing out this generation and consumption, I believe, is most likely the most important problem we have nowadays around energy and AI. But also when I went last year to the Iqony Technology Days conference, I saw AI on any potential application you can imagine. For example, a lot of predictive maintenance and control of these plants.
What you mentioned, those were not like new ideas that we are starting to develop. Yeah, I'm from System Technologies Department. We make software solutions for our own colleagues and also for our customers. Customers are owners of power assets, power plants, wind turbines, PV parks, all those things. And they presented what they did together with us and also with our tools. And so that is, well established, I would say. It's not old-fashioned, but when you come after a project and you present your results, it means all this stuff is already in the market for some time. It's used, it's known, and it's proving the benefits. So it's funny that you mentioned it was all AI. I mean, I was a little bit distracted since I did a lot of video stuff there on the side, but for me, it was engineers talking about what engineers do, how they solve their problems. Yes, we found out that some pump had a problem, and 6 weeks in advance or something like that, we were able to react. For you, it's all AI, and so more or less two sides of the same coin, right?
Yeah. So in the end, it was all for the end business of generating reliable energy. But it was amazing how the whole mindset of the industry is like data-driven decision making. The whole mindset, like, you didn't have a single person in that room that ignored data when they were making decisions. Like, it was like a general sense on that conference, and it's something that I took home, like with a nice, mindset. Like, these guys are actually taking it seriously on the data side. And then the definition of whether or not that's AI or it's just more traditional systems or simulations or equations, it's a different thought. But this mindset of my decisions are supported by the evidence that the data gives me, I think it's fulcral, it's core in AI.
Some of the people that have been there with us, I know them for 14 years now.
Mm-hmm.
I've done different things here in the company, but some of them have worked on and off all the time. And I would even say that this is true what you say. Of course, data is important, but it was 15 years ago and it is now. But the picture is much broader. Back then, you would just look at your generation, your local thing, your local consumption. And now everybody talks about the market prices, the wind forecast, the weather forecast, and it's much more on the table. So maybe even the room for optimization is bigger than it was before.
And when you say it's more, then it leads me to renewables, right? So one thing is controlling your plant, your individual plant, but then we have tons of challenges with renewables, right? Because generation become fully decentralized. Anybody could generate electricity from the roof. So what are the challenges you foresee with renewables energies in the next 10, 20 years, let's say?
Yeah, first of all, we have already a lot of renewables here in Germany by now. When I was still at university some years ago, it was all just starting and growing. So now we have a different situation where when it's like a windy day, we can cover most or all electricity need by wind even. And we have the same capacity in PV. And of course, you need the backup capacity when there is no sun, no wind. To optimize that overall, I think that is currently the challenge, and also to talk about the money and a fair playing field. Is it fairer to tell some power plant that right now you have to shut off just because there's wind somewhere? I mean, fairness in the market, maybe there's some mechanisms that make it fair for everybody when everything is in an established situation. Although I think right now there's still room for optimization. More and more I see talking about hydrogen, which could be a storage there, also consumption in times where there's enough electricity on the market, so that could actually stabilize everything. But then, back in university days, they call it virtual power plant. See, 1 gigawatt is connected and they can remote control that. That is much more sophisticated these days, and that is what we need, some fair mechanism, but also a safe mechanism, right? When I thought about our meeting here, I remember this book, Blackout. Maybe some of you in the audience have read this. It's about smart meters and somebody tampering with it, and suddenly we have a blackout here in Europe. This is just a book, but let's still make it safe, make it reliable, make it with some reason in the background, and then I'm pretty optimistic that we can have the future there. Iqony is all about energy transition and reducing carbon and new technologies. And that's what we want to help our customers there with their transition. And so let's have a talk. Let's see where you are. Let's see what you need. And so many things are possible these days, from hydrogen to district heating to local production and so on. So we have to find the right solution for the tasks that the customers currently have, which are super different than what they had 10, 20 years ago.
And it will be different than the ones that we'll have in 10 or 20 years from now, right?
So what this will be then,
So here we have two issues, right, that you mentioned. One of them is the predictability of the source. How easily can I predict that there will be wind tomorrow or the next week or sun in the next few days? So you can agree beforehand with all the system what can be done. And you can solve that kind of with redundancy, right? If you build infrastructure to have 5 times your energy capacity and it has a low correlation, so whenever you have one source, you don't have the other, etc. So you can balance out with redundancy. Still, you will have a gap, right? So you will have a gap between your capacity, let's say 3 times your capacity on a perfect environment where you have wind, solar, coal, gas, whatever. And then there is the real need. So we have this issue of predictability of the sources, which AI can solve, but still you will need redundancy, because AI cannot solve. AI can mitigate by preventing you by telling you that there will be a low capacity on energy on eolic or on PV, right?
It's an interesting idea because first you said, is it possible to forecast? Yes, it is to some extent, and so we all know that. Yeah, there's certain things that can happen to a 2-week weather forecast, for example. Next thing is the AI, then finding the right things to do. Yeah, also possible. But what I want to bring into the picture now is how does everybody who's participating know that data? Many people have no connection at all. We talk about smaller installations where it's not, nobody can look at this anymore. In a power plant, you have 5 energy engineers looking for 5, 6, 7 units, and everything is looked at and so on. Now we talk about some small, engine powered power plants there for some houses and so on. This reciprocating engine things. Nobody's there. Yeah, nobody will see if it's inefficient, if there's noise and so on. So that's also where the AI needs maybe to keep the extra eye to say, hey, here's something going on. I need support. We have some solution for PV and also for the wind. It's Sensaya, and it's supposed to bring the AI and the data in the cloud for everybody. Yeah, not for my private household, but for a supermarket or such a thing. There you have the weather forecast, and again, GPS for energy data. What do you want? You don't want the fancy screens. You want to know, should I clean today? Should I spend those 5,000 euros or whatever to clean those PV assets, or is it going to rain tomorrow anyways? Those are those things we want to say. But it's all possible, but it's not available for everybody. And that's, I think, what we need to push. Yeah?
Exactly. And then even once we make the data available, we'll have, you mentioned this fairness around decision making. So one thing is having a single supplier that it's providing energy for his market, right? And then he produces as much energy as the market will need, and will try to reduce the cost of producing an excessive amount of energy. But what happens if we have competing energy sources, right? So we have a small power plant here, and then we have renewables. How can we keep the incentives aligned across all of these players in the market? I believe it will be a major issue, because even if we can provide 100% of each one of these sources, how do we keep the right incentives for them aligned?
Yeah, and you have also to look at the operation costs and the capital costs. Yeah, it all has to be in the picture. Now they have those tenders where people have to offer what solution they want to provide. But of course, in the end, it has to be bankable. Yeah, you have to have some certainty about the money that you can make. And we talk about 20 years in the future easily. Yeah? Mm-hmm. So that's the current challenge. Apart from the IT questions and also away from the engineering questions, how is security long term? How viable is such a thing? And yeah, but that's also going on for 10 years, but it's changing and it maybe even getting more complicated as we go.
Yeah. So it all ends up in AI or in real life with having a short-term feedback loop. Do you think that maybe the solution of making a commercial market of energy, which we have nowadays around Europe, was an easy way of self-regulate this system of generation, so people get a direct incentive in the form of a market of energy for producing or stop producing at some points?
I'm not the expert for the energy trading. We have a whole department for that, and they know about the green things and everything. So it could be worth looking with them into more detail. And in general, I think this market is a good thing. I'm not sure if it's fully efficient right now, because also a lot of rules apply, and we have to see where that goes. Yeah. I was a little concerned. It was a few years ago in the UK on a conference where every country said, when we are short, we just buy it on the European market. And if you have one day with 5-6 presentations from different countries in Europe, and everybody tells you, in 2030, when we're going to be a little short, we buy it somewhere else. Somebody has also to be able to produce that at this point.
So maybe it's a feedback loop. It's not a perfect feedback loop. And then, I don't know, we will need some control or more overall decision mechanism around. So do you believe we can conquer renewables without AI?
Yeah, hardly. I mean, of course, if you have a very strict regime and you know everything, you have all the data at hand, of course, you can set up some rules that are just rules and not AI. But in the real world, I think first of all, getting the data is hard, and also to see how valid this data is, and then making recommendations based on that.
Mm-hmm.
So when the AI can help there, it's very good.
Yeah, I see a strong limitation with current approaches of AI for renewables, which is to properly train an AI model, we need good data and data from that specific device and from that specific environment if we want to generate top quality predictions, right? And as the market gets more fragmented, with anyone being able to put a solar panel on the roof with different brands, models, orientations, I mean, you have such a large set, like large variability, that I'm not sure if our traditional way of building AI models will suit that environment, or if we will need to also decentralize the AI models so they can learn actually from the field and from all of these variations of devices. So that's a main concern I have around this approach. What about critical environments, right? For example, with nuclear energy. So we know AI is a black box model. So will we risk at some point putting a black box model into these environments, or what is your takeaway from this?
So my experience is that the nuclear plants in Germany have been very careful and conventional. For example, I know that people are looking for spare parts for those control systems because you cannot change anything. Even analog control systems are still in use because that's the way it was built, that was the way it was approved. And so, maybe as of today, we don't have them anymore in Germany. So that story is from 2-3 years ago. But you can see that they are not like state of the art with everything on a purpose. They want it clear, they want it easy. I know that even 20-25 years ago, we have supplied them with this epsilon model, this first principle thermodynamical model, which is fully transparent, and you can fully check and all inputs, outputs. They are happy to use that, for example, to see what the production is, so they can really go to the allowed limits. So that's really helpful to have more understanding of your data. That's in many cases you have lots of data, but you don't really see what's going on. So that's where such a tool can help. But that is really physics-based, and with the AI, I make a question mark to that. And even with the cloud, I'm not sure. I think nuclear will be very careful when it comes to cloud applications. But the whole power industry is right now, when something is like crucial for the plant, for its production, many customers ask me, hey, can you provide the local solution? And we can provide it locally. We can also provide it in the cloud. It's also nice, and you just need this yearly payment and so on, but still it's super important for many operators to have it on their premise, to be able to pull the plug for anybody else. In Germany, it's a critical infrastructure, something like that. And whenever you are a part of that, you have to be very careful, and you don't want a virus. And I get it. Yeah, I also wouldn't want that.
Yeah, I believe like maybe with nuclear, we wouldn't even need these kind of systems. First of all, it's centralized, so you don't have a decision-making problem across people. You can have the 5 top engineers directly looking at the plant and making the decisions. And it's more predictable, right? So AI typically helps you reduce uncertainty of things that are hard to predict by ourselves. And with nuclear, it's higher risk, but more predictable. So I'm not sure if AI will be needed there, in the sense that it will be needed with, for example, renewables, where you have decentralized production and decision making. So as a whole, I believe there will be a much better point. Another limitation around AI, I believe we talk about that also in the Iqony technology days, which is machines get old, right? These devices get old. And as they get old, or as they get damaged sometimes, the data diverges from the optimal conditions, maybe from the training conditions. And there is this open question, like, should we keep up with the original model that predicts the normal behavior, or should we assume this is the new normal? What's your experience around that field?
Well, first, I would say when customers think that we provide a solution that's like self-learning all the time, they almost want to kick me out of the meeting already, because they know that the condition is changing all the time, and you have certain things that are like on a stable level, and you have other things that you know that will get worse over time, like a filter. You know this filter will get clogged over time. That's just the way it is. And what we shouldn't do is just, because it was good yesterday, so it's all good. But maybe yesterday you were almost very close to the breakage of something. So what is often done is either to ask, do you want it to be modeled, the digital twin, reflecting everything that's relevant for that question there, show everything as new, as built. But yeah, if a power plant, if an asset is 5 years old, 10 years, 20 years, doesn't really matter anymore. So you would compare to after the last overhaul, the last standstill. Maybe the engineers will then say, yeah, that is something that we want to compare to. And if we deviate from that, then we want the warning, even though we know we will deviate. But still, summer, winter changes. Yeah, it's super hot outside, super cold. All that needs to be included, normalized KPIs. So you really see if something is changing. And yeah, that's important. And therefore, nobody wants it to be like all the time automated. Sometimes it's good to say, yeah, that's something we agree on. We as the expert, that's the way you want to compare it to. And if it's better or worse, you want to know. And it's even not an alarm. We often call it anomaly. Something is not as it's supposed to be. And if you have the time, and we often talk about 8-10 weeks before something important happens, we can find it. One example from a wind turbine. Our colleagues here from the headquarters could see that some oil change wasn't properly done, because the oil was okay, but it was not in the same, the change was not in the same way as expected. So that's how sensitive everything can be. But on the other hand, no false alarms. You have to find that out. So.
Okay. So it's, I believe then, a matter, how relevant are these predictions for the end user? So if we self-train the models continuously, yes, we will become better at predicting the day-to-day, but we will be less reliable on the long-term game, maybe.
Maybe both also makes sense, right?
Maybe
what I said now was the engineering view with a larger asset, with a large wind turbine. Maybe for a smaller one, the purely data-driven approach is the right choice. Or in certain cases, both. It depends what the troubles are. And the troubles are not just technical; they can be contractual. They can, it depends what you have to deliver and where your money comes from.
That makes sense. You talk here. You have the GPS of energy data, right? So a GPS is something that it gives you a prediction, but something very important around a GPS is that also it explains you why. For example, when I put on Google Maps, I want to go from A to B, I can see the red segments of the trajectory, right? So that's like the goal of explainable AI, right? So we want to get the prediction, like this is the demand that you will get, but also the explanation, or we want to get the prediction, this turbine will get broken or whatever, but we want the explanation, like the oil was not properly changed, right? Have you seen any interest from your end customers to get these kind of explanations from AI models?
It's not even a question. Those people I talk to would kick me out again.
Okay.
Once I talked on a fair to some guy with some solution similar to ours, but he wouldn't even look at the units of the measurements. So 500 kilograms per hour or degrees Celsius. For his system, it wasn't relevant and could work. I don't know, but from an engineering point, I don't have the trust there. I don't. If we have KPIs that are made for those energy-based values, if it's even for power plants, for PV, for wind, we use the predictive analytics algorithm, and it's our SRSPC with two options there. One is a supervised learning, where I call that a high-quality KPI. So when one of my people I'm talking to knows they have an issue with a certain thing, I don't know, the oil filter in your car, what's relevant. You tell me 1, 2, 3, 4, 5 measurements, and we make the nicest KPI ever. We choose exactly the training period that's relevant for that. And so you come from Portugal, maybe your oil filter KPI is for warm temperatures. Then you come to Germany and we need to talk about it, but it's all super clear. You get an email, something's with your oil, and you know exactly what's up. So super clear, super explanatory. If we use the other approach, the unsupervised learning, the machine learning, where the machine does more or less everything by itself, first of all, we can cover everything, the full car, all tires, everything. But when the alarm comes, you have to spend a little bit more effort to find out what it wants to tell you. It's not Kelvin's KPI sends you an email, So,
for sure. And then you have the accountability issue, right? So if the AI gives you a prediction and you trust that prediction, will you be and make a decision based on that prediction? Will you be accountable for that decision, or will it be the AI?
Well,
Right.
somebody is accountable, and that's what I'm sometimes a bit sad about. If not just with my customers, but in the market, the people get so much information. The control systems give you alarms, and I've spent a couple of weeks in one of the STEAG plants when I started here. I was shocked how many alarms were there. They did some maintenance before, so not everything was fully in operation yet. The people had everything in order, of course, but I was surprised. Yeah, you have this. You think one alarm and you do something, and we talked about 100 alarms per second or something. Yeah? So that was short period. Later it was better. But if any system then gives an alarm, hey, something's wrong with your PV, yeah. What is wrong? What should I do? And now that I know, now I'm in charge. Now, should I call somebody? Should I spend extra money on some maintenance? Can I call my boss? Yeah. But if you know, you cannot unknow. Yeah. And so if you don't do something and it breaks a day later, you might even be liable for not doing something. And that is really, really important. And that, yeah, to really give a clear answer and be able to explain that answer to a certain degree. Customers ask me for root cause analysis. I think that's what they think. If we have this extra module, then everything is super duper clear. We know exactly what to do. But engineering means to work with uncertainties. And so sometimes you cannot 100% say. But if I give an honest assessment of the measurements, of the input data that we use, so why is that email sent out? Then the engineer on site or the operator, they have a good basis to say, okay, now I know what to do. And that is accountability for us and also for them.
So in general, I believe this comes after, human behavior. So humans as a whole are risk adverse, right? That is why we bring this reliability around systems. That's why there is this interest into, for example, explainability around the predictions, because we are sort of risk adverse. But then we tend to over rely on whatever we see on a screen, right? So if we see an alarm there, maybe we will rely on it. If we don't see it, we will believe everything is good. So the balance between false alarms and lack of alarms as a whole should be balanced somehow, not just for a technical metric such as accuracy, but for human behavior, for the human operator out there. I don't want to exhaust them with false alarms, because it will be like in Venezuela is the wolf and Johnny story that Johnny always saying, there is a wolf, there is a wolf, there is a wolf, until nobody trusts him. I don't know what is the German version of that story.
My experience is 2 false alarms and you can go home. Nobody will listen to the 3rd alarm.
Yeah, for sure. So it's never a technical question. It's more of understand, first of all, who is going to analyze this, and then playing with the human reasoning behind those alarms, right?
And you said a lot of data is there. That's absolutely right. But also, can we always trust the data? I've experienced that where some measurement data was just wrong. Yeah, maybe because there's a frozen measurement, so it says 100 degrees, but it's 10 because it's winter by now. But it's still stuck to 100. Yeah. You need to figure that it's kind of easy. But also, there are certain ways to say, well, now I need to overwrite that value here, and I will remember to take that back later on. But if you then come, I don't know, a year later, take some wind farm from somebody, and then you just see the data, then you have to understand where it's coming from, and then you need the transparency and also the accountability of the provider there to say, well, what's going on? And 99% of the data doesn't really matter. Yeah? It's all good, but those 1% where you figure out what's wrong, or if you have to replace something, or you're at the end of warranty and maybe you want some extra fixing or not, that's where you really have to dig deep. And then I just can hope everybody can really explain to those people that need the data how they came to those conclusions and how reliable the data is in that moment.
Of course. How do you help your customers? What kind of relationship do you have at Iqony with your customers?
It's more a partnership relationship than anything else. So it typically means we talk at some point, either because I approach them or they approach us. Then we find out what's possible in that area. We have different solutions that we can pick from. Sometimes it's not like software-based solutions. Sometimes I hand them over to our engineering department, and they can then just talk about technology first. Yeah. So then we have some project phase. So if they really know what they need, then often there's some lengthy talks between our commercial guys and their commercial guys, and I'm kind of in the middle there to make it happen at the end of the day. And because it's bigger companies, right? It's B2B. The bigger the companies are, the more requirements they have, and that's okay. But we need to satisfy that. Good. And then we have a project phase, which is sometimes 3 months, sometimes 6 months together. Often we transfer a lot of knowledge. Customers can choose in the beginning if they want us to provide everything for them and just teach them a little bit how to use it. Or others that are bigger, they have people that are supposed to administer that later on, so they get more training. And then after the project is done, then often this goes into like a service period where they use it on their own, they get support, they get updates from us. And it's typically a longer relation, talking about a couple of years there. And if the customer has more than this one asset, then often they evaluate if it also makes sense in another installation, or they already have the full fleet in their mind, but they start, hey, we have uncertainty here. We have to figure that out. We had a similar solution in the past. And let's figure out what you guys can provide. And I like that. And those customers from around the globe then come to our meeting and present what they did. And I'm more involved in the first part, in the project creation, business development. And then if the project is running smooth, it's often pretty, I don't hear so much about that. I might attend 1 or 2 of the meetings, but no, not hearing of that is a good sign. And then it's so great to see at the end what we discussed and what comes out. So that's why I enjoy those customer presentations and looking forward to the next round.
And is it like this for, let's say, all projects, including the ones that also use, for example, your platforms, or is it more for innovation or innovative projects where you are developing new tools, new models, new systems?
In the end, it's a bit mixed, but overall, we have a standard software in the background, which is developed. We have guys that develop on the Epsilon platform there. We have our online system that is all developed anyways. And a project is then more or less just configuration, either by us or by the customer. So to some parts, those configuration files are fully open. If a customer buys the Epsilon package, they can go to the model, look at everything, even change it, modify it if they know how to do that. So that is just configuration, more or less. Of course, every bigger customer has their special demands and some marketing, some market interface, some prices that they want in there. The suit blowing needs to be like in a specific way. They have one of my customers, they have a super fancy infrared camera system. So the cameras evaluate inside of the hardware where there's dirt and where the boiler is clean. And so, hey guys, can we take this data in some form to put it into your suit blowing? So our system then recommends how to clean the boiler. That's a huge element for efficiency, even if you consider then the market conditions on top. So it's always a little bit of something new, but in general, it's always configuration, and that makes it maintainable, right? That is everything new for everybody, and nobody will be able. Also with the Epsilon, it's used at universities, so you can have a student just jumping in and do something, maybe not make the full model, but it's known knowledge, and they even call the Epsilon people it's the expert family, because it's a few thousand, few hundred people around the globe using it permanently, and they can really help each other out and bringing new ideas to the table.
When you have people at universities using the tool, that's the industry standard, kind of.
Right.
So you are the GPS of energy data. What would you say is Epsilon?
Maybe the very detailed plan to the car, for every screw and for every the manual,
It's like the car manual.
300 pages for a regular car. This.
But is it more for the end user of the car or for the car mechanics?
Well, it's more for the mechanics.
Okay.
So those people that design those things, now it's actually getting more important again, because you have your generation somehow. I had my colleague Laub from Vietnam. I was trying to understand this balcony power plants that we have here in Germany, 600 watts peak, 800 watts peak. And I couldn't understand, like, how should I put both panels to the same direction or not? So we just used this super strong Epsilon tool. He set it up. There's one option for PV. So we have a sun in there. We have the PV. We can play around. We can do some sensitivity analysis. And this is new tasks. Of course, there's special PV things. But what about if we also have some thermal component here, if we have a storage somewhere, if it gets more complicated, then you use more complicated tools. And then, you're not the owner of a private house, but maybe those people that design those quarters here in Berlin, we helped in Tegel. They were changing, they were prosumer oriented things. So each house would be like a consumer of heat, of cold, of electricity, but also a provider of that. So that's a level of complexity, where some expert companies sit together, and then this could be one of those interfaces that they use.
Okay, so you use it a lot for planning and understanding what will happen.
Mm-hmm.
More in the long term, or also in short-term decisions, like on daily operations of the plant?
Well, the Epsilon as a software you would use for long-term planning. You don't need any data interface, nothing. You can just look into the future. I don't know, 1 year, 20 years, solar thermal plants. So when I started here, we talked about projects in India where they wanted to add solar thermal energy to conventional coal-fired power plants. And so Epsilon was helping to say, well, how big could the storage be? What temperature levels should we address? But that is the large-scale application. They are looking into the future. We use the Epsilon as one of the digital twins on a 5-minute basis to really recommend to all the power producers there, hey, you have a problem. Your cooling tower is not working properly. Hey, maybe your engine is not going well, or there's some leakage somewhere. So that is short-term feedback there. But this red alarm, then is super clear if you know there's a model behind that looking at all those things, and you have a very good feeling of what's going on.
Okay, so at some point, it's some form of explainability around these data points, because it's all modeling what's behind ours.
And the customer's involved in the modeling. There's a long quality assurance procedure at the end, but like this half a year, let's say, where they model like a larger thing, like a municipal power producer, some waste to energy asset, something like that. But you would, like, every week you would talk with the customer and say, hey, that's what we have now. We have a question here. Hey, this valve, is it actually open or closed? The data doesn't make sense. So it's more of like an engineering project if you do this. With this, that was all the box thermodynamics, first principle. Data-driven approaches are a bit differently. Yes, you can look at all the data at once. It doesn't need half a year until you have those results. But it depends what the customer needs.
Perfect. Trying to wrap up here. So do you see a future of energy without AI as a whole?
After our talk today, no. I mean, I came here with the picture and also in the preparation that AI is really making decisions all by itself. And I don't see that today in the energy world so much. Somebody is calling the shots. Somebody is making the decisions for who's supplying and who's not. But when we talk about the data that we don't see today and that there's more data needed and to find some kind of a way, some recommendation, I think AI will help a lot. And we also see it's getting easier these days with those GPTs where you can talk to something. I mean, it's not always 100% accurate as my first sessions showed so far. But overall, I think that's the way to make the data easier to understand. And we will not have those super experts for everything. There might be assets that are just some side topic for somebody working on something else all day.
Yeah, for sure. And in a certain sense, I don't believe we will have also AI without efficient energy management, because training these LLMs models is also very energy consuming. For example, on this combustion optimization project, as part of the hands-on data initiative, we're trying to working with you optimizing the cement plants, because it's a very energy demanding project. Maybe we will have a combustion optimization for training LLMs in the future. What kind of energy will you need? How much energy will you need? And when to use that energy to train these AI models will be a challenge.
If you have a flexible electricity price and your cost of that training machine kind of correlates, I think that's a great opportunity. We see right now almost on a daily basis that electricity is cheap, or even I see this is Tibber interface often on LinkedIn, where people say, right now the price is 0 cents. I just pay the 16, 17 cents per kilowatt hour for the grid prices and so on. But if you have this in your mind and maybe a good contract that gives you those things, it's not always that urgent, is it? If you come back a week later with the results for half the price, why not? So I think we will see more flexibility here. And maybe this AI is easier to scale down and up than some power asset that is also lifetime consumption was one of the first topics that we started 30 years ago. Where a metal part, if you heat it up, you cool it down, you have to make sure there's not so much stress in the metal. Of course, now the metal is less than in the past, but still stuff is a little slower than maybe a computer that just says, okay, take a break, 10-minute break. Yeah,
sure.
For a PV panel, it might be more stress than for the computer.
For sure. In the end, I guess it won't be even, maybe we won't even have AI in a sense of artificial. We won't have human intelligence. We'll have a hybrid intelligence of AI and humans collaboratively making these decisions together. Any final word for this episode?
Good. Yeah, final word. There's so much going on. I think energy transition is now everywhere. 10 years ago, when I spoke with customers, they sometimes were like, it doesn't affect us yet. But everybody needs to adapt. And there's possibilities, technologies available now, experts now, prices have changed a lot. So I really hope that we have this kind of an industry where we talk to each other, we learn from each other, and also we have ideas what to do and what is like best practice. It's sometimes like, now we need to do something. That's what I hear from people, but they forget that other people do that already for some time. And also that's maybe what Europe can help the world with. Since we have 20 years of energy transition here already, there's definitely lessons to be learned if you do it somewhere else where they are just starting right now. So I think for a global picture, let's really take all the learnings that we can to really make it as cost efficient, as energy efficient as possible, and also look at the big factors. Look at big savings that we can find rather than saving like this little bit somewhere else. So,
top 3 book recommendations for the audience.
First, I would say Asterix The Goal, because I'm reading that to my daughter every evening. I have some of the original copies from my father and some of the newer copies. And that is a bridge because, of course, for such a long time, not the same authors are working there. So they had to change from the old authors to some new authors. And that is also what I thought about the second book, Jim Collins, Built to Last. During my university work, I was asked there to analyze what is with companies. When do they prevail? When do they fail? I remember until today that they said that 40 years a company can live with one strong boss, some strong chairperson. That is, but if that person wants to retire at some time, or they have to retire at some time, then you would see if a company is set up to prevail, to remain, if it's in the DNA of the company, and not just the one person over there. Right. And the third choice is more of a private one. Everything with John Grisham, those agent stories and everything. I like the way he writes. But when I thought about it, it's the same story there. It started with him, and now other people do it in his style, in his name. I think that's important. Of course, everybody wants to be important for what we do, but also the idea has to be bigger and it's kind of like a team effort, and we have to work on the same topic. So that's my books, from Asterix to agent stories.
Perfect. So it's all about legacy, from the books that you got from your father,
right,
until up to how can we make decisions that last and go beyond us, right? So thank you all for watching and listening until the end. Hope to see you in the next episode of the NILG.AI podcast. Thank you, Dennis.
Thank you, Kelvin. Thank you all. Bye-bye.